Hi, I'm going to take you on an overview of the V001 system. V001 is separated into basically two pieces. There's the core GUI library, which are a set of user interface abstractions that encapsulate a lot of functionality, as well as some automatic loading of modules in the module system. The modules and the user interface objects are separate, and they communicate through some very simple patches that allow you to abstract your modules from your user interface to dynamically create user interfaces for your modules without having to do really any work. So let's get started. I'm going to give you a look at the GUI 100 object, which is a 100 pixel wide user interface object that's dynamic. Well, what does that mean? That means that our user interface object down here can be floating point, integer, toggle, multi-slider, or an UBU menu. The user interface object comes built in with state saving, LFO binding, and MIDI binding. I don't actually have my MIDI device with me, but I'll show you the LFOs in a second. So basically, you send very simple messages that are formatted by your display name, which is what you want to see here, the minimum and the maximum range, what data type you want, and any options that you may have as a symbol for certain message formats. So for example, if you want to set our range between -10 and 30 and set the title to be simply title, you hit this button on the second inlet and we get what we want. We can create an integer number here between 0 to 10, create a toggle box 0 to 1, multi-slider. We've got 40 multi-sliders whose each individual value is between 0 and 10. Here we go, and these are integer. We can put a 1 here for a floating point number, which I'll do right now. And now you'll see we're getting some nice floating point messages down there. And of course we can create our UBU menu. And if you want to have a larger message, we can create another UBU menu here. Now for LFOs and binding, it's quite simple. Let me turn them on. So what I'm doing is I'm sending 3 different LFOs right now, and I can bind my floating point object to one of the LFOs. The second LFO is a ramp, and the third one is a noise function. So that comes out of the box. You get that for free, as well as some state saving and other things like that. I won't get into that right now. So what this lets you do is build dynamic user interfaces that update with basic, very simple message syntax. What we can do is we can wrap our modules with a little bit of glue, and our user interface with a little bit of glue to create dynamic user interfaces that respond to requests from our modules. So let me show you that right now. Module loader and module sender. These two patches work together to create a communication system between the models that are dynamically loaded off of disk at patch runtime and the user interface that you've created in order to select the modules and work with them. So there's some prerequisites for both of these objects. First, you need to have the absolute path to the modules folder. Your modules are stored on disk in a folder called modules, and you can have a bank of modules. In this example, we have some example modules, and we have 4 modules that we have on disk. If you take a look at these modules, it's really quite simple. We have an inlet, an outlet for our message passing. This module is kind of empty, it doesn't do much. And our second inlet and outlet is for initializing the user interface. This is the same syntax that I just showed you earlier. So module 1 will have an integer named variable 1, that's between 0 and 100. And module 4, for example, will have 4 interface elements, a floating point number between 0 and 1, a toggle between 0 and 1, a multi-slider that has 10 sliders, integer, whose range is 0 to 10, and then an UBU menu whose entries contain example entries in UBU menu. Quite simple. So let's get the ball rolling. Here's our blank user interface. We have no modules that we can select, and we have 2 different banks of areas where we can put our modules in. Here we have 2 module loaders. We specify the set of modules we want to load. The reason we do this is because we could potentially have, say, some jitter processing and some MS processing modules that we want to separate as logical groups, so we call those kind of banks. We have the bank name, so these are kind of virtual banks. We can load 2 sets of the same module, have 2 different sets of them. Modules you can set to load serially by simply banging to load the modules, which will then output a bang once it's done loading the modules and propagate that message all the way through. So I'm going to set our path via this patcher, and then I'm going to open this up. We have no modules loaded, and I'm going to load our bad boy up. Modules have loaded. Here you can see we've got 4 modules in here. Now, over here, we've got our options for modules 1 through 4. If I select module 1, lo and behold, 0 to 100. we can see that our module 1 is getting the message as well as our output. So we are in fact communicating to our module. If we go to module 4, we get our full interface. Here's our multi-sliders, our floating point, and our toggle. We all get that for free. So that's a basic idea of how to work with V001, what it does. There's a few more little tricks, but that's about it. Thanks for listening. Bye.